What?
Recording's rolling. It's Tuesday, October 21st. So yesterday was debriefed in a classroom with guys today. We're about halfway through, so I'll finish that. So you guys remember this lab with the turntable? You guys remember this lab with the turntable? Okay. Now I was having you guys hold on to this paper because I wanted to just on the back. But I'm looking how the time's gonna pace out, and I want to get the next topic, conservation of energy, started on Monday. So I think what we're gonna have to do is actually save this turntable friction lab for another day. Actually, where it might be really good, and I've done this in the past too, is actually use this as a review lab. So I should have taught you everything that's going to be on the AP exam by the end of February or so, and then we'll have a solid month or two to review. Okay, and then so we'll pull up turntables and then actually do something. So guys, go ahead and turn this page in. Next opportunity you get, and I will get that in the grade for you. Okay. And then before we switch over to AP Classroom Puzzles, let's just go ahead and look at this anyway. But we'll just do the paper version of this. I know it's not as good as getting your hands on the turntable and the stopwatch. It's like so on, but check that out. Okay. So here's the setup. Actually, I do have this one behind you. Okay. So guys, to get us a pen, guys, what force is keeping these points right here on the turntable? Friction. Guys, isn't it friction? Yes. Guys, and whatever force, in this case, the friction force, that's keeping something moving on a curved path, that's called the what force? Let's see. Centripetal force. So did you guys just tell me this right here? The friction force is providing the centripetal force. That's what you just said, right? Okay. Guys, what if I had you draw a three-body diagram on that point? Here, I'm covering up my three-body diagram. How many total forces do you have to draw? 3? Yeah. Okay. And what are those 3? What, and what?
Gravity, normal force.
There you go. Weight down, normal force holds it up, and then the friction force. And doesn't this friction force always point towards the center of that curved path, center of the circle? Okay. Because here's your step. Here's your first domino, the chain dominoes. It's going to lead to ultimately trying to figure out what's the coefficient of friction between surfaces. Because guys, if there was no friction, well, if you start spinning at the point it wouldn't even move, it would just kind of hover there, like air hockey table, right? Or if it was somehow in motion, then it would very quickly slide off. Maybe it's a tiny friction. Okay, how do you find the coefficient of friction? What if there's a significant amount of friction, like coefficient of friction is like 0.3 or 0.4? Hey guys, what can you substitute for friction force right here? Friction force is equal to what times normal force? Huh? Guys, friction force in terms of normal force. Friction force is equal to what times normal force? Yeah, coefficient of friction. Yeah, you guys remember that? Coefficient of friction? Okay. And if the coin's stuck to the surface, is this static or kinetic friction? It would be static. Yeah, right. Which is actually why I wrote an inequality here. Okay. But, guys, if you set up this experiment in such a way that you were going a little faster, spin a little faster, look, is this angular velocity right here? Until the point finally broke friction, and then you recorded what was that angular velocity. Okay. Then you could make this an equal sign, right? Because it would be like right at the breaking point. Okay. And guys, what formula are you going to use for centripetal force? And don't say mv squared divided by r, because I don't see a v on here, but I do see an omega. So, I mean, there is a v, of course, but in terms of omega. Guys, what is this expression in terms of omega?
Omega squared.
Omega r squared over times r.
M omega squared times r. Right? So it's mv squared divided by r, or m omega squared times r. Remember, you could substitute omega is equal to v divided by r and get this expression. You guys remember that, right? It's like the O'Neill cylinder. You guys remember, every time I break out the O'Neill cylinder poster, has this expression for centripetal force. All right, what next? Guys, what can I substitute for this normal force? mg. Isn't it equivalent to mg?
Yeah.
Right, pretty much mg. Okay, so that's that one. What cancels out?
The mass.
The mass? Mass of the coin? So if I had a heavy coin versus a light coin, that would make no difference. Right? No, the materials matter. If the copper coin versus a nickel coin, that might make a little difference. Because we're looking for those US right here. Right, so it goes like that. Gonna show some algebra. Can you guys solve this? Do all that algebra right here? Right. Alright, so I think that'll be a good review lab probably next semester. Okay, you guys good? Alright, let's flip over to AP Classroom.
Yeah.
Excuse me.